So my hope is that this should be an easy starting spot for an example. So I have here a second
order,
linear, non-homogeneous,
Ordinary difference.
Constant coefficients.
Yeah, this is a different order. So I guess we should do it in the same order.
I definitely see. I never said constant.
This is a Twackledge node.
Exam.
And
Twackledge node.
Don't mess it up.
yeah, so I think this is a Twackle node.
Twackledge node.
Okay.
Where's the CH coming from? It's just the
No
CC.
idea. It's a CN.
No.
The fun thing about this is it creates letter combinations that
Letters
aren't
are
in the
reassociated,
English
right?
language. And also always starts with a number.
I love how we give
Alright.
that the twa.
Yeah. Okay.
Twice.
How do you solve this? Like, so you're given one of these things. What do you start with?
I said 0.
Yeah.
Well,
Try the homogeneous
actually,
version.
Just
right?
multiply both sides by
doesn't
0.
work because you're just one.
Multiply both sides by 0.
It's always the answer.
Okay, so if
What is
you
what?
treat the homogeneous version, right? You got y double prime plus yh is 0,
Yeah.
and then what? Guess e to the rt. Then yh prime is r e to the rt. Yh double prime is r squared e to the rt. So this becomes
R squared plus R squared.
Let me just say
r squared e to the rt plus
R squared
e
plus
to the
R.
rt is 0. And then you can divide by e to the rt because Gabe,
It's identically not zero.
because it is identically not 0.
What? We're saying that. It's true.
Okay, then what?
Oh, they're like, damn, that sucks.
no, it's not.
Then you're like, dude, this is broke, yo.
It's not that bad.
It's a broke spring. It's not real. It's in my head.
So you get r is plus or minus I,
Yeah.
right? And so your solution,
But you don't have to complete the square.
y homogeneous, is given by, yeah, you don't have to complete
I
this.
just do it now by habit. Like,
Put it on your calculator.
It's already a completed square.
It's just a broken square.
And I must admit the person who had the least trouble with that on your exam was Gabe, who got out his calculator and used the quadratic formula.
We were
program.
allowed to
didn't know
use
we were allowed to do that.
calculators.
Yeah, of course.
What? This is as long as you talk to it.
Okay, so you get YH
As
is,
soon as I got to that point, I was like,
I.
oh, dude. Yeah.
so R is I, right? R is plus minus I. So the homogeneous solution then is
Oh, A.
A.
E to the whatever.
E to the T.
E to the I.
I hate this one.
E to
I
the
know.
0.
Yeah, so this would be,
No, the I goes away, right?
right, so this is 0 plus or minus 1I, right?
Yeah. So
So that
it's
would
just
be,
T, E to the T,
No,
sine of
no,
A
it'd be
T.
E to the 0
Right, so
T,
it's-
So just 1
which is
Yeah.
1
sine,
times, why do you do sine first?
because it should be first.
What?
Cosine's
No,
first.
it's cis.
No one cares about cis.
You're the only one
Okay.
out there doing
Says
that.
Cosine and what?
Then you just slap the 1 in there.
Cosine of 1t plus, and then a b, and a,
Since they're
Sine?
the same thing, do we have to put the extra T in that?
Well, it's non-real,
no.
so
So it's
No,
not
you
really-
don't.
no, you do not.
I remember that.
So the only time you have to put the extra t is in there is if
It's a real,
they're actually the same, which means they have to be real.
right?
Complex always comes in pairs.
so Joe,
So I got,
why do you put? Do you want to keep going?
no, go for it.
Why do you put cosine before sine if it's just a constant coefficient and it doesn't matter which one's first anyway?
Because x comes before y, I don't know. Doesn't matter, I was just teasing you.
But-
Yeah, no, the order doesn't matter at all. So, out of this, you came up with this guy here is y1,
Uh,
and this guy here is y2. Right? So you actually know how to solve some of these already. If there's constant coefficients, you have a really good you have really good odds of being able to solve these pretty easily. Now, the other thing is more problematic. And today I'm not going to teach you a varsity approach, I'm just going to teach you the easiest approach. Which is, I would like to get 1 out of a couple derivatives added to the function, right? So what kind of thing are you going to differentiate a couple times and add back to itself and get a number?
Something a couple times big,
Like
Linears,
squares.
some linears.
and just up from that, something that's like
So
parabolish.
if you have, say, x squared, right?
Mhm.
Good guess?
Yeah.
X squared, be like, alright, so I'm just guessing YPs, right? And this is a totally reasonable approach right now. I'm gonna guess YP is x squared. And maybe it'll work and maybe it won't. YP prime is 2x, and YP double prime is 2?
Wait, wouldn't it just be a constant, because if you add a constant, like, cause it's just one?
Hang on. So,
Okay.
looking at this, if I plug this in up there, I get 2 plus x squared equals 1, right? And what you want here is an identically equals. Does that make sense?
So if you did one,
Like you're not trying to find x's where this is true, you're trying to make this as a function equal to that as a function.
That just doesn't work.
Yeah, this just doesn't work. Okay, so this didn't work, why not?
So we said
it doesn't exactly,
Well, because there were x squareds, right? The 1 I could have maybe figured out, but the x squared was problematic.
It's just X.
So, if you guess x, you're like, alright, yp is x. Then yp prime is 1, and yp double prime is
Oh,
None.
sorry.
0.
Really should've just been 1.
So I'd get 0 plus x is supposed to be identically 1? Nah. So what do you guess instead then?
1.
Yeah, guess a number. Notice that you'll get number equals 1, so the number needs to be 1. So, you just kind of guess, right? And you find out yp is 1. Then what?
walk away.
Well, just
plug
add
it into
that.
your, general equation.
Yeah, plug it into the general solution. So, your ultimate solution is y is the part you got out of solving the homogeneous equation. So you got a cosine t plus b sine t plus. Kayla? Perfect.
Sense
I
favoritism.
think that's, I feel like that's, I'm dubious.
You're dubious.
I'm dubious.
About what?
Understand what-
That whole like, oh, let's just pick anything and then.
Yeah,
It's kinda like
so
a puzzle.
really it's like guided, like at this stage, you're finding a particular solution as like guided guesswork, right? You're like, okay, I'm gonna differentiate a couple of times. What am I gonna be left with? Like, okay, on this one, if I start with an x squared, but differentiate a couple times, I'm gonna be left with a constant, that's what I wanna see, but I'm also gonna be left with some x squareds. Crap. Right? So, usually, a good guess is this thing over here is a polynomial, right? I would guess a polynomial of the same degree.
That makes sense.
So let's try another particular case. So let me swap out my particular, or my external forcing function.
That makes it tangent.
Now, does this just work because your q of, or no, your p of x happens to be 0? You gave it to us in the
Oh,
form of y
no.
prime plus p of x.
This will be kind of true in general. So let me say here I have 3x plus 1. Okay. So my guess,
Polynomial of the same degree.
1/3, 1/2 x squared.
yeah, I'm gonna kind of be like, I don't know. yp is like maybe, I don't know, an ax plus b? Okay, so let me try it. Yp prime then would be
I think you need to go up.
a. Yp double prime then would be 0.
So A equals 3 and B equals 1, I don't like this.
Yeah, so in this case, it works out that yp should just be 3x plus 1, right?
I feel like if
I
we
feel like
solve-
this is gonna happen a lot, where you just guess what you need, right?
Yeah, so this is identically what's called the method of undetermined coefficients, which is a long-ass way of saying make a guess and make it a good one. Let me maybe throw on a slightly more complicated one.
Tangent. Oh, gosh.
So what if I had y double prime plus y equals cosine t?
Negative cosine.
Negative sign.
Yeah, I don't know. So you're like, some kind of sine or cosine, right?
Plus minus.
Guys with me? So I'm just gonna go like this. I'm gonna go a cosine t plus b sine t, right?
Okay.
Well, am I guessing sines and cosines?
So then you can see which one you actually
Multitasking for the win.
Yeah, mostly because
Pick
if
one
you
over.
differentiate a cosine, right,
Yeah.
you're gonna get a sine, and then you might have to get rid of that sine, so you're gonna need something. You guys see that? So anytime you guess sines, you should also guess cosines, and similarly. So, what's your yp prime here?
Negative a sine
Yeah.
a
Minus a sine t plus b
cosine
cosine t, and yp double prime.
The other
Negative a cosine t minus b sine t.
Okay, so this plus that is shit.
No.
What happened?
It's at
Everything
a zero.
canceled.
Yeah, it canceled. Why'd it cancel?
Because
Because that was the homogeneous solution. That was a stupid guess. And you all just let me go along with it.
Oh, yeah.
We assume you know
Right.
what you're doing.
So you're like,
I guess
okay,
we
so that's clearly not gonna work.
Just blame it on Jordan, it's fine.
Yeah, Jordan didn't stop.
Jordan. How could you let us try such a foolish endeavor? So what do you need to add to it?
He just has no response.
Jordan's like, I wasn't paying attention. So remember, when something was the homogeneous solution already, right? Like in that case where there's repeated real roots, what do you add?
a t.
Yeah, you slap another t on it. Same deal.
Slap a lambda on there, huh?
Oh,
So let me try this.
Okay.
Maybe it'll work.
of course it will.
But lambda equals t.
So what's yp prime? And I might have sign problems because I left the signs off of this.
Cosine t, a cosine t.
So you're gonna get a cosine t plus
T negative
Negative AT sine.
negative t.
negative at sine t.
Word salad.
Word salad. And
Hey,
then
product rule again.
I'm gonna need my signs. And yp double prime would be
Negative A cosine, negative A sine T,
negative a sine t
minus A sine T,
minus a sine t.
minus AT cosine T.
He's
Oh,
right.
gosh.
Could just factor it out or.
And then you're like.
Wait,
hey,
are these all the same constant?
Yes.
Yeah, you're not recombining.
And I'm gonna have a problem.
Are you
Yeah.
sure?
You guys all see the problem?
Oh yeah.
So
Okay.
those are gonna cancel, right?
True.
And then I have some sines is equal to a cosine.
I mean, there's probably a trig function for this,
So
right?
switch it up over the sign.
Let's just add the sines.
There we go.
So let's add bt sine t. And in my middle term, that's gonna add a plus b sine t and a plus bt cosine t. And then when you differentiate those, you get a
D cosine.
Minus B.
plus b cosine t. And then here
Plus
you
BT, or B cosine T, plus B sine T.
plus b cos t, I think minus
Yeah.
b
Cosine
t sine t.
Do not sometime.
Okay.
Now we get some stuff.
And now I'm supposed to add the bottom and the top and get to this, right?
Right.
Okay, so the whole bottom is actually let me do this first. That guy and that guy are gonna cancel. This guy's not there at all.
And the last two.
And the last two are gonna cancel. And so I have a minus 2a sine t
Plus 2B cosine
plus
T.
2b cosine t. And this is supposed to be identically
Cosine. Or, yeah, cosine.
cosine t. Right, so what's your a? How many sines you got on the right hand side? Remember, you're just trying to make these identically equal as functions.
0.
Yeah, there's no signs over there. So a better be 0,
That's dumb.
and b better be
1/2.
looks like 1/2.
That's just cheating.
So my answer for my y for this, right, was the homogeneous thing I started with, a cosine t plus b sine t, and then your particular is
1. This cosine T.
1/2
1/2 cosine T.
t was a half,
By cosine of t?
and b went up here with these t sine t's.
Oh,
Oh.
I see. Is there no t with the a then? Because it was,
Why did we leave
A is
that
0.
B there then?
oh, but we still have cosine there though. So you're
Sorry.
saying it doesn't matter?
Okay.
Those are just two arbitrary constants from my homogeneous solution, right?
So you're telling me
Yes.
that if I double differentiate that, add it to that, I'm gonna get cosine T.
Yes. Assuming I did the little, I mean, I trusted you all with some of the calculus, so probably.
He just blames it on Chris.
What? Why only on me?
Because you're the only one who gave the answers.
I am so lost
So-
about the method to this, besides just guess and check.
That is kind of the method. So
Oh, God.
the method for undetermined coefficients is guess something of the same type, right? So if it's a polynomial, you guess a polynomial. If it's cosines and sines, you guess cosines and sines. If it's e's to the whatever, you guess e to the whatever, right? Then if that thing happens to be one of the solutions to the homogeneous equation, then you have a bigger problem. You want to slap something extra on there. A t would be a solid start. Does that kind of make sense?
But where does it end?
It ends in a morass of linear algebra.
Oh, well, that's fine.
Okay.